Welcome to Spitfire Mods. This video is going to cover a preliminary setup of your rework station. You've got your profiles. You got your profiles from Spitfire Mods. You know how to program your rework station, which is required at this point. And now the question is, how do you set up your machine? So the next step is going to be board placement and lower heater and upper heater placement. So once your machine is set up, typically your lower heater has already been modified. There's a video on lower heater setup and modification. That's a separate video. This unit has already been modified. Our probe is about 1/4 inch below our board. Our board will fit in the rack like this. You're always going to want to center your board or your work subject to the center of the table typically. So everything is based on a certain flat set of rules, so we're going to want to set that board so that we have it to the center. Now, as you'll notice, this board doesn't really fit in because of these components down the right hand side. So what we're going to do is we're just going to place that board on these bars, and we're going to use these bars as a support. And this is an Scotto HR 6000. Now, this unit does not have a forward and backward movement for the upper nozzle. All it does is go up or down. So what we're going to want to do is we're going to want to adjust our upper nozzle. And what we're doing right now is adjusting the stopper, which tells it how low it can go. So we're going to want to bring that nozzle down. Now, when setting your upper nozzle, and you may have a 3-zone unit with a lower nozzle, when setting your upper nozzle, you're going to want to center it to the chip, front to back, left to right, and you're going to want to bring it down till it almost touches the board. And the way I usually tell is you bring it down quickly, and if it doesn't tap the board, you don't see any board movement, then you're not touching the board. So right now our board is centered on the table. Our lower nozzle is down, and our other probe, you can look up underneath, make sure the probe is not touching the board. And this one is actually touching the board slightly. We just shot the lower heater video, so we probably bent it a little bit. So what we're going to do is we're going to adjust it. It was barely touching the board, so we're going to want to readjust this so that it's slightly lower, but yet even. And we'll adjust that. Bring our component back in. Alright, so we're good on the top, and we're good on the bottom. So our lower probe now is about 1/4 inch below our GPU area. It's in the region of the GPU, very close to it, and we're good to go. So once your unit's programmed, this is good enough. Now, if you're doing a PS3 or an Xbox, typically on a PS3, if you come from this dimension, as you'll see here, there's no components right here, and we took the heat spreader off to show that. There's no components right here, but there are on these 3 areas. So when probing your PS3, you want to slide your probe under the heat spreader, but you don't want to hit any components. So you want to be on this side coming from the CPU. And what you'll find is that coming from the CPU side, that's the side that has no components on all the boards, all the different PS3 boards. Alright, so coming from that direction, that's the area you want to be in, coming from the CPU over to the GPU. Now, another thing we want to cover is how to secure your probe. When you have one of these flimsy probes, you want to draw your fingers out across it to get it straight, so that it's not really bent up. And then you want to slide this under the heat spreader. Our profiles, again, are based on a flat line set of parameters. 1 centimeter in under the GPU heat spreader is the spot for our profiles for PS3. And then your best bet is attach it in one position here under the heat spreader after you cross the CPU. Attach it, and then attach it on the side of the machine. Let me do this somewhere where you can see. So we'll say attach it to the side of the machine right here. And the reason for this is is two things. One is, should this come loose or something, you want a secondary spot that's out of the heat zone. This is out of the heat zone, and that's in the heat zone. This tape can come loose, especially if you reuse it a lot. This is a reused piece of tape. The tape's good for a few shots, and then it pretty much loses its ability to keep everything in place. And then again, set your head in the right spot, and then you're good to go. Now, all profiles on all machines we do, you want the upper unit in place and the lower unit, everything in place when you start. You're not going to move anything during the process. At the end of the process, after you turn the fans on, it is possible to open up your upper heater or move your upper heater away. So if you're using a manual system where it's not an automatic profile system, in other words, it's not going to shut down the cold air right away, you're going to want to move that away manually. So at the end of the process, you'll want to go into cool down mode, and if you have a fixed temperature hitting the top of the chip, you'll want to draw that away from the unit by hand, or put a fan, put a fan on the side of the unit and start blowing cool air across your bottom heater to get rid of that heat and bring the board into a cool down process. So this is your setup for PS3. For Xbox, it's going to be the same process, except one thing's going to change. You're not going to have a heat spreader. So assuming this is an Xbox board, we would change one thing, and that we would take our tip of our probe, and we would basically go under the chip, but you can't really go under the chip because you'll hit the solder balls, so we would go under the chip just a hair. So you would take your probe, you'd find the under the chip spot, you'd put your finger on there, and then you'd secure that here. And again, for Xbox, you want to secure it there and probably another time on the board. So you want to secure it multiple times on the board, so that if this tape starts to come loose, this tape holds the probe in place so that it doesn't shift out, because if it comes out at all, it's going to flip up and lose contact with the component. So right now we were under the edge of the component just a hair, so that the probe isn't going to move around. It's going to stay in place. So the chip's kind of securing that in place, but the tape's also securing it in place. So everything's laid out to keep that in place. So assuming this was an Xbox, you could go under the side. Now if you go under the side, it's much more dangerous because the solder balls are right there. So you can also play it a little safer, and that would be the corners. The corner of an Xbox, if you look at the bottom of the chip, has very few solder balls under it. It actually doesn't have any once you get under the corner for a couple, like a layer or two. So you could actually probe this, find a good spot, access point on the Xbox where you can get under the corner. And if you go under the corner on an Xbox, that's going to leave you plenty of room. So you'd want to put it in there, tape it, and then put your second piece of tape down too as well. So tape it there under the corner like that, and then tape it a second time back here. Now the importance of this probe, and this is your monitoring probe. So what we're showing here is the monitoring probe. Everything else was about your machine and its probes, but this is the monitoring probe. So basically, this is the probe where you want to monitor your set temperature. So if you're running your machine's component up to a certain temperature, that's the probe you're going to do, and then typically you would hold it for 30 seconds and then shut it down. So this is your component probe. Our machines that are modified sometimes have a bottom board sensor, which comes in from the side and bends up. I believe there's a video already on Spitfire Mods with the bottom board sensors. So this is just our setup for doing boards like this. Now, this table here doesn't really secure the board unless you lock it into the grooves, and you can do that on a lot of the boards. If you really had to do that on this board, you'd have to actually slide it to a point where it can go in, like that. Although that puts our GPU too far off, so you're not really going to be able to do that with this machine. If you have arms bolted in here, you can pull this out and then use those arms, and then use the arms off the side to rest under the board. And when you're using arms on a board, you're gonna typically have two arms on the side. You want to go with the 1/3, 1/3, 1/3. So each arm would be in 1/3, and from this side in 1/3. So you split your side into 3 equal pieces of 1/3. And the reason for that is if you split your sides into 1/3, you're going to have very little sag down the edge. You're going to have pretty much no sag. And the reason you're going to have no sag is because your board is about the same weight density wise. So when you go 1/3, 1/3 with your arms, you have the same pressure sagging as you do hanging over, so it actually flexes the board evenly, or most evenly. So if you monitor rack your board on the 1/3, splitting the board into 1/3 sections, that would be good. If you have 3 arms, split it to 25%, and put 3 arms on 25%, and do it that way, or 20%, whatever that comes out to. And then the other thing would be get a center support. With most of these machines, you have a bar that you can run across the middle, and on PS3 and Xbox, you have holes near the GPU. Just hit one of these holes with a center support, and your side supports will take care of the sides, and then that center will keep the center from sagging, and that'll eliminate almost 100% of your sag when running a profile. The other thing is, if you have a lot of sag, most likely your profile is not working correctly. The profiles we use or supply you should eliminate sag almost 100% in the profile, but if for some reason it does not, you would want to contact us or get some support for that unit. Hot air units should be fine. IR units can create sag just because of their heating, their reflective type heat. It's very hot on the surface, not as hot through the density on IR. They heat fast, much faster and much hotter on the surface than hot air. Hot air blows the heat kind of into the component. IR reflects the heat off the component and lets the component come up to temperature, so therefore you have much more warpage in an IR machine than you do in hot air. But that's covered on our hot air versus IR video, which is a separate video. So that pretty much completes your initial preliminary setup video. Again, you're going to want to make sure all your probes are in place, your lower heater probes properly placed. If you have 3 zones on the bottom or 2 zones on the bottom, you'll have a hot air center, but they're internally probed, so you don't really have to do much with those probes. But then place your board, get your components centered to the heat zone and centered for your upper nozzle, and also probe your component properly as shown. And that completes our preliminary setup video. Thanks.